So we'll continue from where we left off. So I did make this, if you guys remember, the actually I'll pull it in. That I have these like flying bits of fiery shapes, and that's because if I put the volume down, it's just to add these guys, just to add a bit more life to the scene, right? And if I scrub forward here, all those little fiery bits. It's just to add a bit more life to the scene. Is I think quite a nice little add-on. So let's drop in a new geometry node. I'm just gonna hide everything else. Shift to normal light. Let's name these burning. No, let's call this cloth vellum. And if you dive inside, now I want to create a couple of, I guess, cloth objects. And let's do it 1 meter by 1 meter and 2 by 2. So it's a simple grid. Now, what I want to do is, I think the easiest way, because I need a couple of randomized versions of these, right? Um, I guess the easiest way to do that would be, so I want to cut this with a sphere. So let's do this. Okay. What if I say I want to have 10 of these, okay? So if I want to have 10 of these, I can do a copy. I wonder if there's a better way to sort of duplicate, I think. But let's do it the way I think that will work. Okay, let's say 10 of these. So I have 10 of those, and then I'm going to say copy number. So copy num, let's call this cloth ID. Okay, now this is an integer, so I want to look through this. Mechanisms, would that still work? Doesn't matter. Let's pick it. Okay, so if I so if I want to run a for loop based on primitive, although they're all one primitive, so this would also work like this, and each time would fetch the each one of these. That's only because it's a single primitive, one of them. And when I duplicate it, it's 9 primitives, and then I want to be iterating over these 9 primitives one by one to add, to give them a cloth detail. But assuming this was a bit more of an interesting shape with more than, actually, let me show you. If it was something like this, then because it will be packed. Is this packed? Let me complete this. Then it will not fetch the whole thing. But since it's one primitive, it's fine. But if it wasn't one primitive, then the natural way would be if we by creating an ID attribute or some unique attribute, and then converting it to a primitive attribute, piece attribute. So let's say primitives, cloth ID. Now, if we try that, that's not gonna work because cloth. I wrote it wrong. Cloth ID. Does this work actually? Oh, so okay. The maybe it's an updated feature in some of the later versions of Houdini because I don't recall integer attributes passing down properly into the piece attribute section of the loops. But this works, so that's good. Let me save our project now here as well. Let's call it 07 cloth. Cloth sim, I guess. All right, so what do I want? I want for each one of these iterations something to happen here, right? So let's say in cloth, okay, out cloth. Well, actually, in piece, because it's not a cloth yet, we'll make it a quote like geo, and then out cloth. Okay, so now in the loops, what I want to do is that I want to do a little boolean. Okay, I want to cut this. And I want to cut this object with a sphere. Okay. Now, my left side, my left input is set as solid, but it's not. It's a surface, right? And then my sphere is a solid, and I want to do an intersection. I want to get the intersecting result of this. Now I have, you know, a circular closed circle, but obviously we want to have a little bit of a broken up shape. So let's put a mountain, and now it's a bit more interesting. But should we make this a bit smaller? Probably. We can make this a notch smaller than, I guess. No, it should be the same size. Let's make it 90% of it, okay? And and then we get the mountain slope. I think the default values are probably fine. Maybe change something, different. Maybe a little bit more detail on the edges would help. Okay, and if you look here, maybe let's try to get a bit more edgy noise. Well, not that much. Oh, it needs to be on the bigger size. No, it's not this one. Let's try simplex maybe. Okay, something like this, I guess. Anyway, it's only for giving it a broken edge. Now, what do I need is kind of give it a bit of a remesh. Okay, so we can use more detail for this. I'm just gonna drop the target size. All right, so it's gonna allow us for our cloth to jump around. But now, if I turn off my single pass, then explode my shapes, can we give it a random position? Well, okay, let's pack this maybe here. Cloud ID. So this is one of them is what 619 polygons. But then when I look here, now I complete my loop. I have 6,000 polygons, but they're all, it doesn't look like anything new because they are all receiving the same seed for the mountain. So because we're in a loop, we kind of need to create a different seed. How do we do that? You can select your block begin and then create meta import node, okay? And then this guy is going to give you a little bit of an information on what's happening for your loop at any given iteration. And then there's a iteration value that we can use to change the seed because iteration value is based on which pass the loop is doing, right? So it's 3 now, which means I can use that value maybe here, which is going to give me a different result. Okay. So how do I access to a detail attribute in Houdini is pretty straightforward. You need I don't know if we can drag and drop. I think I saw someone doing it, but probably not. That would be actually super easy, no? Yeah, I think I saw that. I'm not sure if I have. That would be like, there should be a feature. Okay, well, you can type it. So you go detail, and as soon as you start typing, Houdini will give you options, open parentheses. So this is a value. It's not, it's an integer. It's not a string. If it was a string, it would be details, but right now it's not. So then our first syntax is for pointing where the block begin metadata node is. So if I start typing in piece metadata one, that's correct. And then as soon as I close the double quote, it says how I should be using it. And if you look at the bottom around here, you'll see we have to give the attribute name and the component. Okay, so if it's like if it was like a vector or something. So let's type area. No, not area, sorry. Iteration, right? And then just put a comma and 0 because we have a single integer. And now this should pull in the current iteration number, okay? Which means now if I turn this single pass off, I'm gonna get all these random shapes, okay? And they're all packed. Now let's do something else as well. Let's create a variation number. So let's pack these here, okay, inside the loop. When I come out from the loop, now I have, oh, it's pinned. Now I have, 10 cloth shapes. Now let's give this a name, just in case maybe it will be useful later on. We can call it s at cloth name, whatever. Cloth underscore, which we can use it as an ID as well if needed. Plus, so I need a number now. I cannot just merge numbers with text, so I use itoa, which is integer to array function for VEX. Then I go, okay, I need to use the point number because I packed them, so each point represents a cloth. So then I can say at ptnum semicolon. Now we have a unique name for each one of the cloths. Okay, so cloth name. All good. All right. Now, what do I want? I want a starting position for this cloth before I do a little bit of a sim, right? Okay, let's do something like this, I guess. No, you can be there. Actually, that was better. Okay. Okay, now if I, for example, put a box that is roughly where the, car job area is. Maybe we can look through our other objects as well. It will come handy. So which is going to be around this area, right? So if I dive inside, say show me the other subjects as ghost, let's go something like this, something like this. I think that's a good start. Maybe a little bit further back even. Okay. And now I'm gonna just put a points from volume. Okay, so let's put a points from volume. But before you plug it in, it depends on the size of your object, of course. Just let's put this something high so we just don't like crash the machine. And then let's go to scale, give it a random value. And now I'm gonna create a variation number for the cloth name. So when I use copy to points, it's gonna just randomly distribute it. We don't have to do that crazy loop, copy to points in the loop anymore. It's been integrated. So let's drop in a wrangle. Okay, and then we can say, I guess I at variation equals floor fit, and I'll explain what that means. So actually, let's build it properly. So I want a variation number that is going to match to the cloth name here. Okay, so let's create a variation here as well, which is I at variation equals at ptnum. Okay, so now I have this ID almost like an object ID, and I'm going to create these object IDs here as well, 0 to 9, in these 147 points. Okay, but it's going to be randomly distributed. It will be always 0 to 9, randomly distributed among all these points. So how do I do that? I'm going to say, I would like to have a random number based on point number. Okay. Now if I look here, this is just going to be, because an integer, actually, let me kind of break it down for you. So float, right? So it's like a rand just gave me a 0 to 1 float values for each position. Now, what I can do is that I can extend this from 0 to 1. Instead of 0 to 1, I can do say, hey, how many variations of values do I want? I want 0 to 9, right? So I can say, let's fit this. Let's use the fit function. So then I can say, fit is, I'm saying, fit these values that are by default from 0 to 1 into 0 to, I think, 11 now. So it's going to be, no, it's going to be 10, right? Let's check. Okay, so here I have values from now, float values from 0 all the way to almost 11, okay? But I have variation of 0 to 9. So let's take that back to 10, okay? So I'm now 0 to 9. Okie dokie, that's good. But it's a float, so I need a integer, right? So now if I just do like this variation, it's gonna be okay, but you're gonna get this like something is not right. I'm fixing it for you kind of error. So what I do not to kind of to avoid that is that now we can say if I create a floor here, okay. Now it's gonna, I'm just using extra functions to show you how to organize these values. Delete the letter. Okay, now I have these values that are floored to the bottom if you need to. You don't need to use it in this case because you can simply put a here integer. And it's now it's an integer, but the output is a float, so it's kind of like forcing the point back. But if I put an I here now, it's not going to complain. It's expecting an integer and it's receiving an integer, and the values are 0 to 9, so that's good. So that's our variation. And now let's create a attribute randomize. Let's create like a little orient attributes to have a random orientation as these values are received. And is this random? Yes. And let's create, this is orient. Let's create a random color attribute as well, just for the sake of it. Okay, CT, it's a vector, that's all good. And finally, p-scale to give different dimensions. Okay, that's also good. Now I can just simply use copy to points. Copy to points. These are my sources. This is my destination. But I still have to activate and put in here variation. Okay, now I have many clothes, but I think these are a little too large to compare in comparison to my the version that I did before. So let's kind of, I guess, scale them down. You can also use scale, and scale is going to give you thin ones, long ones. It's probably a bit more interesting, honestly. So let's keep it scale because scale, Houdini will respect scale instead of p-scale, which is going to give you a non-uniform scaling solutions. Okay. So what do we do next? We need to unpack. We're going to pass this information into now vellum and vellum cloth. Okay, and in general, the very next thing we do is just, in this one especially, because I just need these to float around with the fire velocity field, really. So I just need a solver now. Let's go to first frame. Let's hide all the other things. No, don't solve. Let's go to frame 45, I guess. Did we cache this from first frame? No, it's fine. So let's do 45. Okay. Now if I press play, everything should just fall down, but I have a ground, so let's enable ground collision, which is the good side anyway. And now if I press play, it should just work, which is just falling down, which is fine. However, now what do we need to do is we need to, I believe, do some advection. So which means we need to bring in our fire simulation. So let's drop in an object merge. And I think that's in firewall render is coming from our firewall. So here is our velocity field that we would like to use. So let's plug this guy in here. And let's do a little test now. Back to Claude Willem. And here, I'm just gonna do a little cleanup in case I need to do some work. Generally speaking, we should be able to just pull in this straight into the solvers and then drop there an advec node, but you know, I'm just gonna keep it clean. So I have a velocity field here. Actually, we should probably double check where we are in. Okay, so that we need to pull this guy a little bit back because we won't have otherwise a velocity field to be advecting. But I think in the previous one I simulated inside and I just kind of like shifted them forward even. I think that's what I did, to be fair. Okay, so here we have one VDB. I'm just gonna hold its first frame here, so I kind of get like an initial clamp to first. I think like so. There's always some higher velocity to shift things around. Let's drop a null. Okay, and advection volume. Cool. Let's go inside the volume solver. Is our closer. Okay, let's drop in a pop advec by volumes. Okay, and this guy is gonna be feeding in this guy. So that should work by default. I'm not entirely sure if I had to convert this to the Houdini volumes, but let's see. Yeah, it seems like it's working. Okay. I do believe I put a pop speed limit just so things don't go crazy fast. And I think I put it like 3 meters per second or per frame. I think this is units per second. Okay. And then I think I just added on top a random force. So things move around a bit more. So I'm gonna put this to 4. Okay, let me disable this. Let's see how this behavior is. So it's kind of falling down. And then they're also shifting around because of the, I guess, the pop force. And now if I go back, pop advec with volume. So this is going to be a little bit slower now, probably because it's trying to load the velocity field and things are moving around. So what I didn't like, I think, was I wanted like a more constant flow in the air. I think I did reduce the gravity on the solver. So if that's what you desire, you know, you can. And let me see, I think we can arrange it from the forces here. Yeah, I did multiply it by, I don't know, a quarter. So, you know, things will fall down easier. And I turned off self collision. Um, no, this is self enable external. This is friction, self collision, just for the sake of speed, because I really don't need that kind of fidelity. Then, as usual, we drop in an attribute delete. Just, you know, delete everything you don't need. As you guys can see, this comes in with a huge amount of attributes. So all I need, however, is because I don't have UVs on these, I guess that's it. Maybe one thing I'd like to do here actually is when I unpack, let's preserve cloth name in case we want to do something with it. Okay. And then, and because it's a unique ID as well, so we can create, maybe some other things. Oh, there's one more thing. If you want to stick some textures to it, make sure you provide a REST attribute. Let's do this here. Okay. All right. Now this is good to go, I think. We have velocity and let me see. Let's double check. REST. We won't be needing P scale after because we baked out pretty much, because we're going to be deforming these things, so they have to follow the shape. So cloth name. Let's reset the solver. There's a cloth name we want to preserve, velocity we want to preserve, and rest we want to preserve. Okay, delete not selected. So if I look here, all good. Let's just delete those groups as well. Group delete. And now I can cache. I'm just going to copy paste one of our cache nodes. I guess we can use the current. No, we don't have one here. We can use this one. Just give it a new name. Make sure you don't overwrite on your cache. So cloth sim. Cloth sim. Okay, I'm just gonna cache this out and then we'll come back and see the results. Okay, shouldn't be long. Actually, are we retiming this? Yes, we're retiming this as well, but post-retime, this is fine. So we can save it to 100 frames. Okay, the simulation is finished. So let's check the result. And clothes flying around and big bada boom. Now we only need to apply the retimer. It's a constant topology geo, so it should just work out of the box. And it should kind of slow down when the car lands, but slow-mo. All right, cool. So the clothes are ready. Now we gotta put the clothes on fire. And let's save this file first, and then save as cloth pyro. Okay, so let's put I think another geo node here. Let's call it cloth pyro or cloth fire actually, because we call everything, and then I'm gonna remove that space there. Okay, so that's pretty straightforward. We're just gonna import our geometry output here with an object merge. Let's pin it, remove transforms if there aren't any, but it's a habit. I'm gonna pull this in. If I go back in here now, actually, should I do the retime before or after? I think this one was kind of doing a little bit of flickering, so let's do both. Instead of bringing the retime, I'm going to bring the sim. Let's copy this retime anyway into cloth fire because we're going to use it later on. Now we start from frame 45, so I'm going to put like a time shift here. Say start from clamp to, I guess, delete 45. So if I go previous frames, I will have data. Time blend, if I need to go and do a little bit of a sub step. And I think this one is worth mentioning. And I see this occasionally not being checked properly. So we have a sim here, right? If I scrub, things are moving. But that's only showing me per frame motion, correct? Yes. Now, if I click on this little guy here, I can turn off integer frame values. And I can say, show me 1/10 of every frame as well. And if I close this, and if I start, and then you will see that it's set to this like a float version, right? And if I hit move to the next frame, it's going to switch, right? But notice what's happening is that it's not actually moving between frames. So now if I was doing a simulation with a substep of 10, essentially I would not be feeding a moving source to the solver. So that's what timeline does, right? It kind of gives you that in between approximation position data, okay? And then if you feed, excuse me, then if you feed this into the simulation, now you're going to get a lot more accurate in between substep data, which occasionally can solve the substepping issue in the simulations. Now, what I definitely don't want is not to simulate fire on each one of those. Let's do a little bit of a randomization. I'm going to do a delete small parts, so I want only fire on the bigger parts. Labs, delete small parts. I use this quite often. Just, I guess, maybe, okay, something small. So if we go like this, all right, so I just got these bigger pieces now. Let's set these on fire. Okay, so let's do a little bit of sourcing now. I'm gonna do a point up. And remember, we did create a rest attribute so we could stick textures to it. And then in this scenario, it could be the amount of temperature. Let's put a turbulent noise, rest to P. So if I plug this to CD, and if I look through this, and if I look here, do I have the flag on? Yes. My colors are here. And should be changing color. Do I have color here before? No, I don't have color. No, it's fine. Oh, maybe it is showing. It's not just showing. No, it's sometimes gets bugged. No, it is there. It's just that maybe the frequency is not high enough. Okay, let's dive inside. I'm gonna put a little ramp so I can squeeze out some of those values, and since this is going to be a float, so we're gonna have a spline, and then I'm gonna do a very basic 3 exports. Density. Temperature and burn. Increase the roughness a little bit, leave it this 1. And now if I just need to probably kind of take this up a little bit. It's just that it's not showing. Is it there because of the viewport is? Why are you not showing me the proper colors? But it should be fine because the values are here. Oh, but they're all same. So there's a problem. Let's investigate. Rest. Oh, yes. It's not a float. It's a vector. So now we have color and they will stick. It will not swim. It will stick like a texture. Cool. Let's look through them here. Let's continue. Just gonna add a little bit attribute randomize for velocities. And then just drop a volume rasterize. Select our attributes. A little too big. Okay, now I should have, if I make this background dark. Okay, so we did the volume rasterize. Well, now we need to put down a PYRO Solver. And we'll try the GPU version again. Now, which means we need to change from sparse to minimal. And we need to make sure, first let's go big voxel size so we don't crash the machine. And let's go back, say start frame is 45. Oops. And then we kind of need to define our, the bounding box area. So it's going to be, ground level, obviously. So that's give or take, right? And then we can figure out what to do later. Actually, yeah, this is the right area. Because that's where our source is. Okay, that should be good. I guess they'll go a little bit left and right. We'll find out. Okay, then I would like this to start at 45. I want the sourcing to be throughout the simulation range. Oops, not like that. And I don't need to cycle. Okay, now what else do we need to check? We need to make sure. Actually, let's press play, see what's gonna happen. Okay, because we were super low resolution. Let's go 0.1, press play. Yeah, something is happening, still very low res. I believe I recorded mine at 0.02, so I'm gonna put now 0.4. Press play. All right, there's something happening. And oh, they died because it's the simulation finished. Okay, I guess we can go to our sourcing, boost up our numbers a little bit. I think density can stay like that. Maybe temperature is at 3. Press play. Still not really. Let's make this a little bit more explosive. I guess we can go to fields. We want this to probably dissipate really fast so they don't make this like long streaks. I guess flame is fine. Temperature, cooling rate should be probably high because if you want it to get like cold really quick, just keep looking. Okay, there's some redness, which we will turn into flames. That's fine. Let's turn on speed because you're gonna play disturbance by speed. Let's go to shape. Buoyancy is fine. Now disturbance. I wanna add disturbance, a high disturbance, like a really quick fire. Turbulence, yeah, shredding, high shredding. Just rolling numbers here. Not even sure what's gonna come out. Okay, we are barely seeing this, so let's look at why we're barely seeing it. Let's increase this. Okay, so if I increase the intensity to 250, I'll get something more. Ooh, okay, something is still, I think it's the disturbance is super high because we're not using any fields. Yes, use a control field. Let's call it speed, and I want it to be maybe something like this. Okay, so there's still like a long line. So I'm gonna put, actually, let's put this to 2. Press play. It's not crazy enough. I want to focus on a smaller area, so I'm gonna do this until I get the behavior right. Okay. Now I can increase the resolution, obviously. So let's play with the settings. Let's See what happens if we put that still. So it's just gonna emit smoke. We don't care about that. Let's put a 10 temperature. Let's put 10 burn. Ooh, okay. So this is becoming too aggressive. Let's do 4. Our initial velocities are not as interesting as I would like them to be. So I'm gonna just add velocity. I'm gonna put like a 4. Actually, let's put a 4, yeah. Actually, we can do it in the sim as well. Let's press play. Not much happening. Maybe if we go, let me try this turbulence. Actually, I'm gonna turn this off. Our dissipation is not fast enough, so let's make that faster. This would be in the fields. Okay, let's leave it like this. And then I think it's this guy here is not responding the way I want it to be. Let me turn this off. Let's check, double check. Okay, so that's obviously too much. Let's dial this down, 10. Let's look through the camera. It's more like it. It's still too visible. I think let's put this 100, which we can sort out with the render as well. Okay, let's dial down disturbance. Okay, let's do 4. Is 4 going too low? That's fine. All right. Now, because our object is still moving a little bit fast, let's put the max stop steps to 2 to see if it's going to help with the stop steps. A bit better. What if I do 4? Okay, obviously it's much better, but now it's slowing down. So let's go back to 2. Let me put 1 here. Okay, it's a bit more fiery. That's fine. I'll keep it. If I add velocity, let me try one more thing. I'm gonna do a pull. Not much of a difference. Let's do it again. Maybe I want 4 times more craziness. Okay, I don't think it's gonna make big difference at this point. Let's just make sure that we have enough space for all of our fires. Press play. Oh, there's one more thing we can do to avoid these gaps. So if I go to a frame, I'm going to turn this off so we can see it a bit better. That's because there's a lot of gap happening between the pieces, but because we have velocity, and if I turn this off first, I should have velocity here, right? We do, yes. Then I can apply velocity, and it's going to stretch. It's going to almost like fill up the data based on the direction it's going. So if I look at here, this guy, it's probably going up. It's traveling upwards, but if I turn on velocity blur, and longer I make the shutter, taller the tail will become. But then here we have a little bit of attribute randomize as well. Okay. Let's change to Gaussian, give it a little bit more craziness. Okay, so maybe this will be a bit more interesting now. No, I don't want to get inside. Yeah, this became a little crazy now. Let's press play. Yeah, that's too much. Okay, let's, I guess, dial down on the sources a bit more. Press play. That's too much because our source is too wide now. So let's go here, say I want Not that long, but it's long. Okay, if I press play. Okay, it's a lot more fiery. It's a bit more magic fiery, but I think it's better. All right, so let's go back to this Cloud Realm cache node, drop it in Cloud Fire, and I'm just gonna cache this Cloud Fire, Cloud Fire. Okay, first let me cache this low res. And once it's done, I'm gonna come back. Okay, so this is finished. Now, where's our retime node? Let's try that in. One in the volumes, probably by advection. We just have to see if it's gonna actually work once it slows down. Yeah, this looks like it's fine. All right. So this is our fire, but this, we made this one a little bit too dense, but we're gonna play in the shader to make it less dense. Okay, so now I need to put two more render nodes. So I guess we can put it here. We'll call this one code render. Then this one goes to the volumes, geo, cloth, fire, render. So object merge it in here. This is gonna be retime, right? Yeah, I'm gonna go here, here, cloth fire, retime. Okay, so this guy we're gonna render here. For Redshift, we have to do this cleanup, which we will. Cloth render, object merge. Retimed. Where's our retime node? Oh, we need another one. Okay. So let's not break the convention. Let's copy this. Come on. And we would like it to go there. It's got attributes. That's all good. And render is fine. And I think the next thing is literally the heat haze, because heat haze is obviously an important part of this tutorial. So if I look at if I press the video again, you'll see the road and everything is wobbling, and that's coming from the heat haze. If you look at the harder edges, especially here in slow-mo, you see that clearly there's a big amount of wobble. So I'm going to stop the lesson, and then we're going to continue in the next one for the heat haze. Thank you for watching.